Hello guys, in this video I want to talk about a abelian group as mod nz, and I want to show you the geometric interpretation of that group and how that group is obtained basically from. So first I talk about that a little bit more in my article that you can find on my website. It's a short article when I explain what is like the modular arithmetic and how it's possible that 2 plus 2, for example, is equal to 0. But a short summary that when you're going to take a real line, on this real line you're going to indicate the set of integers, which is like 0, 1, 2, -1, and etc. And if you're going kind of to take your real line and wrap into a circle, then you're going to have kind of a circle with corresponding points, and you're going to wrap that. For example, 0 is going to glue with 2, 1 is going to be glued with -1, and etc. So in that case, if I'm going to glue in that way, I'm going to have a circle only with 2 points, which is 0 and 1, and that is represented by points 0, 2, 4, and etc. Or in other words, like 0 is going to be an equivalence class. And then this picture here, for example, is geometric interpretation. What is z mod 2z? So z mod 2z, in other points, is going to be a set with 2 points with a certain type of operation. So in the same way, we're going to define z mod nz, let's say, as a set of n points, a1 up to an, and etc. in the way that I'm going to sketch a circle, and you can visualize it. In this circle, I'm going to inscribe the n-gon, where each of the vertex of that n-gon is going to be corresponding point from my set z mod nz. So this point is going to be a1, this point is going to be a2, a3, dot dot dot, and the last point is going to be an. So we know what is our set. Our set is going to be a set of n points, but then what is our operation? In other words, if I want to take element ai times element aj, then what is going to be the resulting element? And the resulting element is going to be the following. If I'm going to take my n-gon, and you know that inscribed angle of the whole circle is going to be 360 degrees. And if I want to find the inscribed angle between two adjacent vertices, then that angle, let's call it alpha, is going to be equal to 2 pi over n. Because basically, if I have an n-gon, I'm going to divide my 360s by n equal parts. So then what is going to be corresponding a0? A0 then going to means rotate a circle by 0 degrees. Or in other words, like by 0 pi. Then what is going to be my AI? AI is going to be rotate my circle by 2 pi over n times I, kind of radians or slash. You can translate that into degrees, and you're going to have corresponding degrees. And you can see when I is equal to 0, then this expression over here is going to be 0 over here. So that's why I know that element over here that I'm going to multiply is going to be rotate my circle by 2 pi over ni plus 2 pi over nj degrees. But that doesn't, sorry, like radians. But in other words, it's rotating by 2 pi over n, I plus j. And that is going to be exactly the element of I plus j if I plus j in total is going to be less than n, but it's going to be the higher than n. You can just need to subtract the multiply of 2 pi, or a couple of multiples of 2 pi. Yeah, so let's kind of do a small example, and I'm going to be done with this video. Imagine that if I have a triangular over here, and I'm going to indicate this by 1, 2, and 3, then what is going to be my a0? A0, if I'm going to act, I'm going to obtain just the corresponding triangle, which is going to be the same. So it's going to be 1, 2, 3. But if I want then apply rotation by a1, it means I want to rotate my triangle by how many? By 120 degrees. And in that case, what I'm going to obtain? I'm going to obtain triangle where 1 is going to go to 2, 2 is going to go to 3, and 3 is going to go to 1. So I'm going to obtain 3, 1, and 2. And so that's why a1, for example, times a1 is going to be equal to a2, where a2 is going to be rotate my circle by 240 degrees, and etc. So that's it. So basically z mod nz is going to be just a set of endpoints on a circle that is inscribed by n-gon, and the operation are given by rotation by 2 pi I over n.